Here are the systematic rules for naming di, tri, and other polysubstituted benzenes. So let's just review these and then we'll do some examples. First thing, identify the parent. The parent can either be benzene or it can be one of those common derivatives like toluene or phenol. Step 2, we're going to number the substituents to give the overall lowest numbering, which that's something we commonly do with rings. There is a caveat here. If one of those common derivatives is your parent, the substituent associated with that automatically becomes carbon 1. So if you have an aniline with some other group on it, you just blindly go ahead and pick that substituent that's part of the aniline as carbon 1. From there, you would number to give the lowest possible numbering. If you run into a numbering tie, then you can switch to alphabetical priorities. When we assemble the name, it's like we would any other IUPAC name. List your substituents alphabetically, along with their locations, followed by the parent name. And the parent will either be benzene or the name of the common derivatives. With the ortho, meta, and para terms, we can use those for di-substituted benzenes, but if you have more than 2 substituents, stick with just regular numbering. Okay, here's our first example. We have the benzene ring, but what you want to spot is that one of those common derivatives is present. So it's not just a benzene, but instead we have toluene. Because toluene is our parent, its substituent is going to automatically be carbon 1. Then we'll number around the ring to give the lowest possible numbering. So in this case, for the IUPAC name, list the substituents followed by the parent. We have 3-bromo toluene. You could also not use the numbering because it's a di-substituted benzene, and instead call this meta-bromotoluene. Or shorten it and just write M-bromotoluene. In our next example, we have a tri-substituted benzene. None of these substituents are part of a common derivative. So here, our parent is simply going to be the benzene ring. The next thing we want to do is number our substituents. But what you might recognize is that there's 2 equivalent numbering schemes. We can start at the chlorine and go clockwise, and we have something at 1, 2, and 3. Or we can go in the reverse, and we can start at the ethyl. Since there's a tie, what we want to do is switch to alphabetical priority. So think about the number 1 substituent in both cases. We can either have 1 ethyl or we can have 1 chloro. The chloro is alphabetically prioritized over the ethyl group. So that means we're not going to use the one on the right, we're going to use the one on the left. So let's write our other substituents out. We have at carbon 2 an isopropyl, and at carbon 3, an ethyl. To assemble the name, alphabetize your substituents and follow that with the parent. 1-chloro comes first. Next, the E in ethyl. Next, the I in isopropyl. And finally, the parent is benzene. In our next example, what you want to recognize is the OH on the ring gives us a common derivative as the parent. This is phenol. Now, if you didn't have that as the parent, the way you would want to number this would be starting 1, 2, 3, and 4 would be your lowest substituent numbering. But because we have that common derivative as the parent, we have to make the OH carbon 1. Now number clockwise or counterclockwise to give the lowest numbering of substituents. In this case, counterclockwise will be lower. Okay, so let's alphabetize the substituents. B comes first for bromo. 5-bromo. Next, the C in chloro. And then finally, the parent is phenol. In the final example, what we have here is toluene within the structure. So that's our common derivative. This carbon that has the CH3 group will be carbon 1, and then it doesn't matter which way we number, it's equivalent in both directions. So for this one, we have nitro groups at 2, 4, and 6. So the name would be 2, 4, 6, trinitro, toluene. This is a common structure that you may have heard of before. TNT. This is an explosive. One final thing I'll give you just a little bit of insight on. Sometimes people will ask, what happens if we have the substituent of 2 common derivatives within one structure? For example, what if you have an NH2 for aniline and a CH3 for toluene? And there's various rules as far as what gets priority. The one thing that I will go ahead and at least tell you is that the CH3 is kind of the lowest priority. So in this case, the aniline would be the parent functional group. And the CH3 would just be a methyl substituent.